All right, Merry Christmas, and today we're going to be doing day 24 in Advent of Code. The first part of this challenge is that we're going to get a bunch of different operators, the AND, OR, and XOR operators. What AND does is we have a left gate and a right gate, for example, and if they are both ones, then it outputs 1. Otherwise, if one of them is 1 or if none of them are 1, if all of them are 0, then it outputs 0. That's what the AND gate is. The OR gate, it only outputs 1 if one of them is 1, but also if both of them are 1, because at least one of them is a 1. And then we have the exclusive OR gate, which says that exclusively one of them has to be a 1. If both are 1, then it returns a 0. What do we do with these operators? Well, we get the input file, which is right here, and we have two different parts. We have some sort of variables or numbers or gates that have some specific values. So we can see that all of these gates have a specific value, and then we have to do something with them. And what we have to do is to put an operator on two different ones to get a result. So x00, which we know is a 1, then we do an AND operator with the y00, which is a 0. So 1 and 0 becomes 0, because that's what happens when you do an AND operator. And we put it inside z00. So now we know that z00 is a 0. Once we do all of these different things, we get a bunch of different answers, and not all of them are going to start with Z, so there's a bunch of different letters as well. And what they want us to do is to only take the Z ones. We can do this by sorting it to make it easier, or by just looking, okay, which one has a Z. But we do have to sort it when we get all the Zs, because Z00 is the least significant digit in a number that we create from all of the Zs that is in base 2. So we can see here Z00 has a 0, and then another 0, 0, 1, 0. So 0, 0, 0, 1, 0. So the more we go up, this is the 5th most significant digit, or 6th, because it starts from 0. And this is the 13th most significant digit, which would be this 0 over here. So we just put them in a number. And this one is in base 2 right now. So what we want to do is to convert it into base 10 or into decimal. And it produces 2024 in this example. So what they want us to do is to do this with the entire input file that we get, and to count all of the Zs up and then convert it into decimal and give them the answer. So if we did not need to get this information, just converting it would be really easy, but there's a couple extra steps that we have to do to get there. So the first thing that we do to solve part 1 is that we open it from the file as we have it here, and we have a little hint here, which is that this line is empty, so we know that it switches from one type of data to the other type of data when there is a new line character. So what I've done is this part here, which is to parse the input. So the first data and the second data will correspond to the first data above here, and then the second data below here. So we initialize a switch as false, and it only switches once it finds the line that has \n. And I wanted to do that because at first I want to add to the first data until it finds the \n, at which point it switches the switch to true, and then it continues to this else statement, and it only appends to the second data, which is this over here. So it will add the line, and we will strip it for any weird characters. That's what we do here. But right now we only have every single line into a variable, into a list that we have either first data or second data. They're not really parsed. So we clean the data, we make a dictionary of the first clean and second clean, and what we do here is we iterate through every piece of information in first data, which I call first, and then we're gonna have the left side and the right side. As we can see, we have y37, 2 dots is equal to 0, so we're gonna have the left side if we split it by 2 dots, and then the right side, which is gonna be the 0. So once we split it by the 2 dots, we make the right side into an integer, so it's not just a 0 as a string or something else, and then we put the left as the index in the first clean. For the second, we do something similar, but we can see that there's a lot more things going on, and what I found the easiest doing is to just split it by the space, and then what we're going to get is we're going to get this KTR, XOR, CPC, the arrows, and then Z27. So we're going to get 5 different things. We don't actually need the arrows, but I just have to put them into a variable so that it plays nicely and it works. So we have data1 operator, data2 arrow, and then the answer that we get, but I call it data3. And we do that by splitting the second by space. We could also not say anything because by default it is space. And then what we do is we add to the second clean with the variable data3. So we want the answer to be sort of what we look for when we want to get this thing here. And then we add the data1, data2, and the operator. Then what we do is that we look for every wire in the second clean keys, and we also have wire values, which we copy from the first clean, because when we do this, we can sort of overwrite the data that we got before, and we don't want to do that. So we just want to copy the original information that they've given us and then just sort of compute what's going on here. And they've specified that in the question as well. So the operate function, it takes the data3. If the value is already calculated, then we can just return it. Otherwise, it resolves the inputs recursively. So if the data1 is not already in the wire values, then it calls the operate function again and again and again until it is eventually added. So if the operator is AND, or XOR, we do something different. So here are the actual operators that we use in Python. This is the AND operator, this is the OR operator, this is the exclusive OR operator. So we do different operations on the data1 and the data2, and then we put them into data3 as they wanted us to do, to be able to get the answer of whatever should be on the right side. Then we return all of the wire values, and what we do with them is that we sort them for each key, and we select them if they start with a Z. And then we have all of the Z wires. We don't have to do it this way, but it's just simpler to just call the sorted function that's already implemented in Python. Then once we have the sorted wires, we flip it, because right now it's the wrong way. So we say 2 dots, 2 dots, -1 to be able to just flip the entire list that we have. And we get a binary result, which we want into a decimal result. So when you convert something into an integer, you can actually give it a second value as input, and that is in what base it was, and then it will make it into base 10. So now it will be in decimal. So if we run this, we will see that we will get the binary result to just see what it was. So we can see that it's about 3 times as long as the decimal result, and that's about right. And this is the decimal result, so 559 something something. So if we look at the answer, that was the correct answer. Now for part 2, what we have to do is if we imagine that all of these different things are sort of connected. So if we imagine that we have A here and we have B, and then we do some kind of operator, AND operator, and then this one creates C, right? So this is what one line would do. But imagine that this Z36 is also in some other line somewhere else, and magically that number isn't, but some other numbers will be, and they will sort of make each other up. So the C will make D together with maybe F, and then this would be with the OR operator, or the exclusive OR operator, and then F will be itself made of something else, and then these will be made of something else. So what the problem is that we can make a sort of a graph, acyclical graph, that does not sort of point into itself. So the B will never point to the A, and then the A will point to the F, and then the D back down. So this way we could sort of traverse all kinds of weird ways through the graph, but it is not like that. It is an acyclical graph, as they've mentioned it in the problem, and we can sort of only traverse upwards. And what the problem is that somewhere 8 of them have been swapped with each other. So if we imagine that we swap these two, the values of whatever they have, so if C was 1 and F was 2, then now they've swapped with each other, and we sort of get the wrong answer somewhere. And to be able to determine, okay, which ones are swapped and how do we find them and swap them back, we look from the bottom up, and we look, okay, if we do the AND operator of A and B, and we get a 1, and we see that the C is actually a 0, then it means, okay, the C is wrong. This should not be where it is. Then we have to find another one that's also wrong, and then if we see that those two match, then we can swap them and see if everything works fine. So we have to find 8 spaces like this, and what they want us to return is all of the spaces sort of concatenated together alphabetically with a comma in between. So this was a bit difficult for how much time I've had to work on this. So I've taken most of this from Hyperneutrino. He also makes solutions on this. But the input, to get the input is the same way. And then we separate the formulas, and right now we only need the formulas, which is the second part. We're actually not going to use the first part at all. And we make the wires, we verified that the Z ones are where they should be in their place. We verify intermediate XOR, verify carry bit, and basically this is a way to solve it by, let's see if I can step all the way back. This is a way to solve it by imagining that, okay, so Z00 is the least significant bit, right? So it's going to be a 0, and then Z01, let's say it's a 1, but this bit right here is the 1's place, this is the 2's place, this is the 4's place, this is the 8's place, and so on and so forth. So we get maybe up to 24 zeros, so up to Z24. And at some point, one of the digits is flipped. So instead of being a 0, it's a 1, or vice versa. And not just one of them, but 8 of the spaces actually. But since we know that the Z is made from, for example, X0 plus, or not plus, sorry, AND operator, let's say, Y0 is equal to Z0. Then we can see, okay, we can look at the number that we actually have, and is this true, and is this operator the same thing as what we have here? So we do this for all of the different Z's, and we check, okay, at what place is it actually wrong, and how did we get there? How come it's wrong? What operators are not where they should be? So maybe we should swap an AND operator with an OR operator somewhere. So that's what we want to look for. And this is what this entire program does. And at the end, when we find the swaps, we also add them to the swaps list here so that we can print them later. And I don't know how fast it's going to run while I'm recording as well. But if we scroll up, we can see it prints it one by one. So the CMV it found to be in the wrong place together with Z17. So those two were the ones that swapped, this one, and then there were 4 more, but it's going to take a while to run. So I'm just going to show what answer I got here. So this was the ones that were swapped for me, and this code seemed to work just fine. So big shout out to Hyperneutrino for explaining the problem and having the solution as well. And for the time complexities of part 1, we have N, which is number of wires, and G, which is number of gates. And the time complexity total is N log N plus G, which is almost N squared, so pretty bad. But this is mostly just because we are sorting Z over here, which takes N log N. And we could just select all of them that contain Z, which would be N complexity, and then actually sort them, which would be a lot less things to sort, so it would be faster. But since the input is not that big, I did not bother to actually exclude the Z first and then sort it. And the space complexity of part 1 is N plus G. So now for part 2, what we have is also the number of wires and the number of gates, and the time complexity is actually quite bad, since we have to iterate a lot of different times through a huge tree, a huge network of all different things that link to each other, and then see where one of them is wrong, and then find another one, find where the second one is wrong, and then swap them. So there's a lot of different operations and things that we have to repeat and things that we have to check, and we have to keep everything in memory as well. But luckily we don't have to keep several copies of it, so the time space complexity is just G plus N, which is not too bad. But the time complexity is G cubed times N, And of course G is not that many gates, but it's still quite a lot that it's G cubed. So maybe this is not the best implementation that there could be, but it works in under a minute even with this huge input that we have. So that was the time and space complexity. If you guys want to join the leaderboard before Advent of Code ends tomorrow, you guys can put the code that I will leave in the description. And thank you for watching. Happy holidays, and see you tomorrow on the last day.